So already in the morning, we have discussed about the type of flow. We've already discussed the type of flow. And here we are going to discuss some of the problems. Okay. So here mostly we will see how to identify the flow. Here they will give various kind of solutions, various kind of equations they will be providing. And here we are going to find out the respective thing. So I hope all of you can see the question, right? So in this question, what they have asked, the velocity distribution for the flow of an incompressible fluid is given by the equation. Okay, this equation U is given, V is given, Z is W is given. Now it can be also given in this form. The possible ways they can ask a question like this, that is V equals to 3 minus x I, okay, 4 plus 2y into y into j plus, sorry, 2 minus z into k. So this, instead of giving this u, v and w, they can ask in this form. Now both the forms are same. In some textbook they have written v equals to vxi plus vy of j plus z of k, or it is also means by u of I, v of j and w of k. The meaning is same. Okay, meaning is same. All right. So here they have given the u, v and w. Now, so first of all, tell me what is the dimension of the flow. What is the dimension of the flow? Whether it is 1D, 2D or 3D.
3D.
It is
3D.
a very good. It is a 3D because we have both the U, V and W. Okay. Here you might think that here we, now here the Y is 0. Y is 0 and Z is also 0. But whenever you have some functions, if your W is 0, that means we can say this flow can becomes a 2D. There is existence of U, existence of V, but W not, W is 0, then we can say that flow is 2D. Please keep that in mind. All right. Now what they have said, we have to find or prove that, what is the proof? Whether the flow is compressible fluid or not. To understand whether the flow is compressible or not, we have to use continuity equation. Okay? Using okay. Now what is continuity equation? We have dou u by dou x plus dou v by dou y plus dou w by, we have dou z equal to 0. Now in case if it is a two-dimensional, then we have to write only this one. Okay, this is again satisfy the three-dimensional flow, satisfies for the three-dimensional flow. Now what you have to do, you have to find this differentiation with respect to x, differentiation with respect to y, and here differentiation with respect to z. Now when you do dou u by dou x, what will you get? The constant, then it become minus 1. Will you get minus 1? Then dou v by dou y, if you do, again it become plus 2. Then next we have dou
plus
w.
1.
Yes, you get plus or minus? You get minus
Oh, sorry,
1.
ma'am. Sorry. -1.
Minus 1. See, you have to be very careful with the symbols. Okay, you have to be careful with the symbols. Okay. Now, you're going to substitute these values. Let me change the color. Now, you're going to substitute these values over here. Now, you have to see whether it's satisfying that. Then minus 1, this is plus 2, this is again minus 1. It comes to 0. That means the flow is incompressible flow. Okay. The question comes in such a way also. They will give you the equation. Okay. They will give you the equation and they will ask you to find whether the flow is like I have asked you in the exam. Okay. So whether the flow is 2D, 3D, incompressible or compressible. Okay. Clear? Can we switch to next problem? Please respond. So I will switch.
Yes, ma'am.
Okay. Keep a note. Whenever they're asking for incompressible, this is the formula. Okay, this is the formula for incompressible one. And if it is equating to 0, you will get it. Now, this is how you get lag in your exam. Okay, you have studied what is incompressible, you know what is irrotational, but this is what you get lag. Now, moving to the next question. Got it. Now, next question is the velocity component in two-dimensional velocity field for an incompressible fluid are expressed as. So here we have again the same thing. Okay? Here also we have the same thing. Now what they have asked here to find the properties. The question is incomplete. I think it is missing. It is not coming up. I don't know why. So here they are asked to find what is the dimension of the flow, that is 1D, 2D or 3D flow, or whether the flow is rotational or not. That means either you can give a rotational or irrotational. You need to find out that. All right. So again, now first tell me over here, what is the nature of the flow? It is a 2D or 3D. What is the nature of the flow? It is a 2D or 3D.
Today, ma'am.
It's absolutely right. 2D. Why? Because it's a function of x and y. Okay, because it's a function of x and y. Now let's solve that. Let me take the ink. All right. Now how you can solve? Now what they have asked, now your motor to find whether the flow is irrotational or not. Now which formula will you use for irrotational? Anybody?
Ma'am, that
Continue
del square
question.
pi by del x.
Yes,
It's dou
yes.
square u
No,
by
ma'am.
dou x square plus dou square v by dou y square is equal to 0.
Yes, ma'am.
Yes, we have some angular velocity formula. You remember? Angular velocity of z is equals to half of. I hope all of you are copying with them with practicing with me. Am I right?
Yes, ma'am.
All are
Yes,
practicing.
ma'am.
Okay, good. Now, you. I hope all of you remember the formula. What is the formula? Dou v. Now, when we have dou v, we will have the opposite component. What we'll have? Not the y. We will have the x. We will have the x. Now, minus we will have dou u. That means we'll have the opposite component, that is dou y. Okay. When there is a omega, that is a angular velocity equals to half of dou v by dou x minus dou u by dou y. Now, what you have to do? You have to find out this one of dou by dou x and this one with the dou u by dou y. Now, what will be the value if you differentiate that with respect to y, what will you get? 3y power 2 by 3 plus, if you differentiate, it will become 0 minus, it will become constant. All right, we will get this. Now over here, if you differentiate with respect to x, what will you get? Y square minus, it will become 0.
X square, ma'am.
Yes,
X square.
yes, yeah, 3 and this one will get cancelled off. Now what you have to do, you have to substitute over in this equation. Let's see, after substituting, y square minus x square, and here you get y square minus x square. Can cancel off, it is coming to 0. That means there is no angular velocity. Okay. Now sometimes they can ask in such a way also whether the presence of angular velocity. Already we have discussed in the morning lecture that they can ask in such a way also. Angular velocity, whether vorticity. Okay. So here vorticity will be also be 0 because this parameter represents your vorticity. All right. Clear? Shall we move to the next problem? Let me know once you're ready.
Can I ask a question, please?
Sure, of course.
Ma'am, when to use the second derivative, ma'am? For example, if suppose the question is irrotational, steady, and then one more component, like we can use the second derivative, no, ma'am. Dou square u by dou x square. That can we use that here?
Dou square.
Dou
Which one
square
you're
u
talking?
by dou square u by dou x square plus dou square v by dou y square is equal to 0. Can we
It
use
was
that?
dou phi. It was a
Yes,
dou
ma'am. Yes,
phi,
ma'am. It's
isn't it?
dou phi square by dou x square. Is that formula, ma'am?
Okay. Let's. Okay, you want to go in that way. Let me erase everything. All right. Let me erase all ink. Okay. Now, let me try in your way. Now you are telling to find out rotational dou square phi by dou x square. That is a Laplace equation you are talking about, right? Phi by dou y square by dou square phi by dou z square equal to 0. Now z is not there since it is a stream function. Z won't be there because already it is a 2D flow, right? Now in this, what is phi then? What is phi?
Phi or psi, ma'am? It's psi actually.
Sorry, what is psi? What is psi?
Streamlines.
How you can relate? It is a streamline. How you can relate with this u and v? How you
U
can
is
relate
equal
with them?
to del psi by del y. U is equal to del psi by del y, ma'am. Del psi by del y.
By del y. All right. Now that means we have the u is this one. You have to, what you have to do to find out the psi, you have to integrate. Otherwise, if you consider this is a del psi, then again you have to further differentiate with respect to y. Psi by del y is u. To your main motto to get del psi, sorry, del square phi by del y square means what? Can I say like this? Can I write like this? Did you get my point? Isn't it getting more complex? To find out the parameters, first you need to find out the psi, then you will find out again, you will differentiate that and find out. So if you feel convenient to finding in this way, you can proceed. Okay, so no problem. Now I request all of you to find out and tell me what you're getting in it. I hope you're getting that. What is the value you're getting? Is this value is correct or not? Let me know.
Yes,
If
ma'am.
this, yes, right? Because if we have dou psi by dou y equals to u, then our main motto to find out dou square psi by dou y square. That means, what does it mean? Dou by dou y, dou psi by dou y. And what is dou psi by dou y? Is u. Now again you have to differentiate this one with respect
Ma'am,
to y. Yes,
we are getting the sum, ma'am.
we are getting the same. You will
Yes,
get the
ma'am.
same, obviously. Right? Here you have to do with the x. The thing will be same. But here it is much complex. If you see the previous one was much, I think, easy. So again, it is up to you, whichever way you proceed. Right? Whatever the way you proceed, it has to come the same. All right?
Okay, ma'am. Okay, ma'am.
Now we can move to the next. Okay. Now here is something, a different question. Okay. So here we have the stream function. The stream function is given in psi. And here we have to find out the velocity component. And they have given the points. These are the points x and y. These are the points of x and y. Now how you can solve? That means the psi function is given. From that psi function you have to find the u and v. After finding the u and v, you are going to find out the main component, that is a capital V. How you can find the capital V? Root over small u plus small v square. Small u square plus small v square. Now if you have, maybe if the phi is given instead of psi, if the phi is given, if you have u, v and w, then you have to write u square, v square and w square. So this is how you will get the velocity, resultant velocity. And in the question, if they ask the direction, okay, if they ask the direction, that is, you have to use mostly the direction they ask for stream function. Okay. Tan equals to v by u. That is this v by u. Okay. Now let's solve the question. Here they have given this phi function. All right. Sorry, psi function. So what is u? Tell me the formula of u.
Del psi by del y.
Psi by del y.
Del y.
Now look into the formula. Just ensure that whether there is a negative or positive is there. Look into the notes which I've given. Just ensure that whether there is a negative is there or positive is there. The value is negative or positive. Whether it's negative or positive, ensure that once again. Okay. Now solve and tell me what will be the value. What will be the value?
Actually, what were you telling, ma'am? Negative? I don't understand. What is it?
U equals to dou psi by dou y, whether it's a negative or positive.
Negative only, ma'am.
Huh?
Positive only, ma'am.
Positive.
Positive. Look into the notes. Just look into the notes are given.
U is equal to minus dou psi by dou y.
Exactly. Okay. Look into the notes. Okay. Here we have just a second. And when you consider V, it is positive dou psi by dou x. Okay. There is a difference. Okay. When we are considering the psi, u equals to minus dou psi by dou y, and for the v plus dou psi by dou x. And in case of velocity potential, all we have the minus. In case of velocity potential, everywhere we have the minus. U equals to minus of, keep that in mind. This is the formula. Sorry. All right. Now, if you solve this one, what will you get? If you solve the u, minus of this will become plus 3y square.
3, ma'am.
Huh?
Y square and then
3.
6x, ma'am.
3? How?
It's actually
Means
V
magnitude
6x.
I have put. Magnitude.
Okay. Right. Now, after putting magnitude, u of 3 comma 1, we get 3 units. Okay, units. Now here, when you solve dou by dou x, 3x square minus y cube will becomes, this will get cancelled off.
6x, ma'am.
18.
You'll have 6x.
6x, ma'am. So it's 18.
Yes.
18.
And when you solve the 3 comma 1, you get 18 units. Okay, 18 units. Now what is they have asked? The magnitude. To find out the magnitude, that means you have to do root over 3 square
U
plus
square plus
18
V square.
square. So what?
18.248.
Okay, it's root over or the total answer you're telling?
Total answer, ma'am.
18.25.
248.
25
Okay,
is, ma'am.
4.25 units. Okay, now one more thing. Listen to it very carefully. In the questions, in the gate questions, they ask how much decimal points we have to give the answer. Sometimes they ask maybe of um, 2 decimal places or 3 decimal places. So if they ask for 2 decimal places, so you have to round off and give the answer. Okay, you have to round off and give the answer. If they're giving 3 decimal places, then accordingly you have to give it. Okay, so you have to give 18 to 5. Okay, if there is 2 decimal place. If there is 3, then accordingly you have to give 4, 8. Is that clear? So they will have, whenever there is a gate kind of numerical thing, they will have some kind of ranges. They will keep some ranges. Suppose the answer is 18 point something, they will keep the ranges 18 to 19. That is a range. Okay, so ensure that very carefully, and you have to put the points properly. They also look into that factor. Okay, did you get my point? Okay, so shall we move to the next one? Let me know. Did you get it? Am I audible?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, all right. So let me move to the next question. Okay. Now here they have asked lot many things. Okay, in the previous thing, let's find out if they ask you to find that what will be the expected directions. Let's find out that also. What will be the expected directions? How you can find the directions?
Tan theta is equal to V by U.
Tan theta equals to small
V
v
by
by
U.
small u. Okay. That
80,
means
80.53 degree, ma'am.
theta will becomes 80.
80.53.
Okay. All right. So fine. Now these are the possible things they can also ask. Okay. Moving to the next. Okay. Okay. Now what they have asked in this problem, they have already declared that in a two-dimensional incompressible flow, in a fluid velocity component are given by two fluid component has been given. That is U and V. U and V has been given. Show that the flow satisfy the continuity equations and obtain an expression for an stream function. If the flow is potential or that means it is an irrotational, obtain also the expression for the velocity potential. That means they have only given the U and V. From there, we have to first check whether it is satisfying the continuity equation or not. First thing, that is a first thing we have to do. Then we have to obtain a stream function from there. Okay. Then we have to check the flow is irrotational or not. Third. And the fourth one is we have to, if it's satisfying the irrotational flow, first we have to check. If it satisfies, then we have to find the fourth one is a velocity potential. Now from this question, you can understand by single equation, that is a U and V, you can expect to get this 4 different types of questions. Okay. Now, how will you find the continuity equation? Let's move to the fresh page. Next page. Now, what is the given data? Please, let's note down the given data. U equals to x minus 4y. Okay. Right. Now, U is given as x minus 4y. And what is a V? Minus y minus 4x. Okay. Minus y minus 4x. Now first we have to find out the continuity equation. Then we have to check whether it is if it is satisfying, then we have to find the stream function continuity equation. We have to find the stream function. We have to check the circulations, that means rotational or not. Then we have to check the, if satisfies the, you have to find out the velocity potential. Okay. Now, how will you check the continuity equation? Does it satisfies? How will you use the simple formula?
Del U by del X plus del V by del Y equal to 0.
Is equal to 0.
Yes, absolutely. Now you have to satisfy that. You have to satisfy that if whether it is coming 0 or not. Now, if you do differentiate this one,
It's coming 0, ma'am.
it's coming 0. How much you're getting? You're getting 1.
Yes, ma'am.
Minus
And
1.
when you're differentiating this
1
one, you're
minus
also
1.
getting minus 1. Right? It is getting 0. So it is satisfying the continuity
Yes, ma'am.
equation. Now, when you're satisfying the continuity equation, that means what? The flow is
Incompressible.
incompressible. The flow is steady, incompressible. Okay. Now, okay, done. This flow is satisfying this condition. Now, how will you find the stream function? How will you find the stream function? Again, you
As
need to
discussed
recall.
earlier, like U and V
Yes,
formula has come.
yes. What is the formula? We had
Minus dou psi by dou
minus
y.
dou psi by dou opposite. They were opposite with each other. That means we will use y. Okay. That means it is equivalent to x minus 4y. Next we have v. V means dou psi by dou x, which is equivalent to the minus y or x. Okay. Now how we can do? Let's consider any one of it. Let's take this one. Okay. Now when you resolve this one, then you will take like this. Then minus dou psi equals to x minus 4y becomes dou y. Now take the minus over this side, other side, and integrate both the ends. So you get psi equals to minus xy plus 4y square by 2. Okay? Plus some function plus some function. Now what kind of function it will be? What kind of function it will be? Here we are differentiating with respect to y. That means some function which is independent of that, of y. That means there is something, definitely some function was there with respect to x. Did you get my point? Did you get my point?
Yes, ma'am.
Okay. Now psi equals to minus xy plus 2y square plus fx. Now sometimes in the when you're finding the MCQs or something, the fx won't be there. That means if they ask you to find the fx value, that means you have to proceed the next. How you can proceed with the next? So sometimes in the options, if they have given the fx value, you can stop till here. Okay, you can stop till here. If they have not given any constant or that means constant of integration or any kind of fx function, that means you have to find out what is your that constant function. Now how to find out the constant function? Here it is the function with respect to x, right? We have done with which is independent, which is independent. If it is independent, that means you have to differentiate with respect to x. Okay, that means you have to differentiate dou this above equation with respect to x. That is I will just give me a moment. I will just come back. All right. So please remember this equation. Okay. Phi xi equals to minus xy plus 2y square plus function of x. I will again repeat from there. Okay. Now you have this thing. Erase all. Xi equals to minus xy. We have then plus 2y square plus the function of x. Is that clear till here? Now what we are going to do, we are going to take partially differentiating with respect to x. We are differentiating with respect to x. Why? Because here the integrate constant, okay, which is independent of the factor y. Because here we have differentiated with respect to y, right? Sorry, we have integrated with respect to y. Now, when you're integrating any factor with respect to y and we are getting the constant, that has to be some function of x, right? So, to understand this factor, what is that integral constant, we will differentiate with respect to x. Okay. Now, let's consider f of x is r. F of x is k. Now, let's differentiate of x equals to, when you differentiate that with respect to minus y plus again 0, then you get, since it is a k is a function of x, so we will partially differentiate with respect to x. Clear? Now what is the dou psi by dou x? Previously we have done the dou psi by dou x. Let's look into it. Dou psi by dou x is minus y minus 4x. So we can write in place of dou psi by dou x, we can write minus y minus 4x. We are substituting from there. Okay. Minus y minus 4x equals to minus y plus dou k by dou x. We'll get cancel off. We will get dou k by dou x will become 4x. Then equals to 4x dou x. Integrating both the side, we will get k equals to 4x differentiation square by 2. So we will get k value 2x square. Now what we are going to do is we are just substituting the k value over here. K value over here. So we will get the stream function like something like this. It was plus or minus. I think I missed one thing. See, minus I have missed. So it is minus 2x square. Okay. Did you get the point?
Yes, ma'am.
Okay. So this is the stream function. Okay. Now next what you have to find? You have to find the irrotational. How you can find? There are two ways to find irrotational. One is this method. Will equate to 0. Another one is there. This is another method. Okay. See, please try to write the formula without seeing. Okay. So that will be the mode of practice. Am I right with the formula? Have I whether I have written the formula correctly? Let me know.
Yes, ma'am, correct.
Okay, so you can use either of this formula. Now, when you substitute that over here, what will you get? It has to be either 0 or not equal to 0. If it's satisfying equal to 0, that means it will be a irrotational flow.
It is irrotational, ma'am.
It is getting equal to 0.
Yes, ma'am.
Okay, that means if it is getting equal to 0, that means it is irrotational. It has become irrotational. Now, what they have asked in the question, if it becomes irrotational, then you have to find out the velocity potential, that is phi. Okay, how you can find the phi? How
Del
you
phi
can
by del
find
x equal to my minus u. Del
yes
phi by del x equal to minus u. Then integrate,
del
we will
phi
get
by
phi.
del phi
Del
by
x
del x
del
equals to
x minus u.
okay minus u. That's good.
Then integrate, ma'am,
Okay,
with
that's
respect
good. And you have the u. What is the u value? You have I think
my x minus 4y.
x minus 4y.
4y.
So using this, you can find out. That means here also will become minus, isn't it?
Yes, ma'am.
Become x minus x
Minus
plus
x.
4y. Then phi, if you want to find phi, to phi equals to minus x plus 4y, you have to do x. Integrate that. Let me erase this part completely. So we have dou phi equals to minus x plus 4y with a dou x. So we will have phi equals to minus function of, we will have the function of y. What we'll have? We will have the function of y. Now, are you getting the same thing? Now,
Yes, ma'am.
yes. Yeah.
Can you just repeat the procedure of finding the phi form? After finding the string function psi, like how to proceed with phi? Can you tell it again?
How to
After
find the
finding
phi?
the
Okay. Now, okay. Now in the given data, they have given what is a u. U is x minus 4y. Okay. Now what is mean by u? I can write u can be of positive, negative of dou psi by dou opposite. If it
y.
is y, it means y. And phi, it will be proper way. It will be there. This is for the, am I right? So can I take this relation now? Here I'm using this relation. Got it?
Yes,
I'm
ma'am.
using this relation and I have got this value. Got it?
Yes, ma'am.
Okay. Now again we have some function of y. So let me take as capital C. Let me take this value as a capital C, which is a function of y. Now again, how I have to find the constant? You have to find differentiating with partially with respect to, I'm going to do with respect to the y. So dou phi by dou y will becomes, it will become 0 of this part, right? Now what I will get over here, differentiating, get plus 4x plus dou c by dou y. Now again, from the previous equation, we know what is the v value is minus y minus 4x. Now what is v? Minus dou phi by dou y. So can I write like this? This minus and minus will get cancelled off. That means dou phi by dou y becomes y plus 4x. Can I say like that? Now I'm gonna substitute this value over here. Y plus 4x equals to 4x plus dou c by dou y. It will get cancelled off. Then you will have dou c equals to y dou y, integral both the side. C equals to y square by 2. Substitute over here, substitute over there, you will get the phi. What will be the phi? Minus x square by 2 plus 4xy. Then you will have again plus y square by 2. Are you getting that? Let me know.
Yes, ma'am. Yes, ma'am.
Okay. All right.
Can you wait for 1 or 2 minutes?
Yes, yes. See, do not see. You have to practice it. I
So I
will
practice
request.
simultaneously.
Yeah.
I'm just doing
Yes, please do it. So you can understand from this question that in one given data, the how many factors they are asking you to find out. So many factors. And the same thing they ask in your GATE examination. All right. Now, another possible question can happen. Okay. From this problem. So let me, yeah. Now they have given you this equation. Okay. What was the equation they have given? They have given you this u and v. They have given you this u and v. Now from this equation, they will ask you whether the velocity potential, okay, whether the velocity potential will exist or not. Okay. The question can be asked like whether the velocity potential will exist on this parameter or not. Potential. Am I audible? Am I audible?
Yes, no.
Yes, ma'am. Now
Okay,
audible.
okay. If I'm not audible, let me know. All right.
Ma'am.
Yes.
Hello.
Yes.
Ma'am,
Yes.
what is the mean? Means all if u and v is there, then we can find out velocity potential.
No. That's what I'm telling. If u and v is present, then also you have to understand whether it will exist the velocity potential or not. Okay. I will. I will tell you. I will explain that only. I think. Am I audible clearly, or there is some glitch in my internet? I'm audible clearly, right? Because simultaneously I'm recording the session for the future use. Okay. So I feel there is some just give me 2 minutes. Okay. Whether my screen is visible? Whether my screen is visible, right?
Yes, ma'am.
Yes, ma'am.
Okay. Just give me the recording. There is some issues in my recording because many of you are not attending the class. Then it and you can use that for your future reference, right? So I'm recording the session actually. And all right, I think some issues are there. It is not working. So okay, what I will do is I will give you one problem, you solve. For the meanwhile, I will sort that issues. Okay. Now this is a problem. Okay. You can see the question. Can you see the question? So is it easy? Can you solve it? Please solve the problem. Here, what they have given the U.
Ma'am, option D, ma'am.
Option D.
D.
Let's this
No,
one.
ma'am.
This one. No. This
No,
one.
ma'am. No, no, ma'am.
See, how will you resolve? The given data is U is given A e power x. What they have given in the question, they have said the flow is two-dimensional, okay, incompressible, steady flow. That means what formula we have to satisfy? Continuity equation. Dou u by dou x plus dou v by dou y equal to 0. Okay. Now dou u by dou x equals to minus dou v by dou y. Now what is dou u by dou x? If you differentiate this one, what will be the value? You will get a e power x. Will you get the same value? You'll get the same value, isn't it? So substitute over here a e power x equals to minus dou v by dou y. What will you get? Dou v equals to minus of a e power x into dou y. Integrate both the side. V equals to, you will have minus a is constant, it will come outside. Integration of e power x will also be same into y plus function of, since we are integrating with respect to y, then we will have the function of what? Function of x. Now tell me, what is the right answer? What is the right answer now?
C, ma'am. Option C.
Now we have the option C. Okay? All right?
Yes, ma'am.
Clear? Is it clear to all of you? Let me know.
Yes, ma'am.
Okay. Shall we move to the next question?
Yes, ma'am.
Okay. Okay. I was telling one more important point. Just let me take the ink. Okay. There was a velocity potential. I request please mute yourself. Okay, thank you so much. Then stream function. Okay, velocity potential and stream function. Now velocity potential is 3-dimensional and stream function is 2-dimensional. Now there was a question that they have given some u function has been given and v function has been given. Now they can also ask a question whether this particular flow, okay, u and v will satisfy the velocity potential or not. Now to understand that whether this will satisfy, first you need to understand velocity potential is such kind of flow which has to be a irrotational. It has to be a irrotational. But stream function, it can be rotational or irrotational. Okay. So how to find irrotational? That means this is a function. That is dou v. First, then we'll have the x, then we'll have the u by y. So if it is equals to 0, that means if the angular velocity becomes 0, then only we can say that this particular u and v will satisfy the velocity potential or not. So you can expect such kind of questions also. I hope you got the point. Like previously we have some equations like x minus 4y, then minus y minus 4 x, something like that. You got a question. Now it may depends on the function u and v function, whether it will satisfy or not. Okay, if it does not satisfies, that means if it becomes not equal to 0, that means it will satisfy the stream function but not the velocity potential. Clear? Is that clear to all of you? Let me know. Shall I move to the next? Shall I move to the next? Let me know.
Yes, ma'am. Sure, ma'am. Yes, ma'am.
Okay. Now let's solve this problem. Now solve this problem. What is the problem? A two-dimensional flow field has a velocities along the x and y directions given by u equals to x squared t and v equals to minus 2xyt respectively, where t is time. Now the equation of stream functions is, so from here you have to use the equation of stream function. Now let me tell you what is the equation of stream functions. Very simple equation. In three-dimensional, u by dx equals to v by dy and w by dz. Okay, this is a stream function equations. Now here, as they have said two-dimensional, they have said only u and v. So you can take this equation. Okay, so in that equation you can get now u dv equals to v dx equation you can take, or you can take vice versa. You can also take dx u by dy by v. Now what you have to find? You have to find the equation of streamline. How will you do that? Have you started solving, or are you still thinking? Whenever you have the u and v, substitute the values. What you will do? Dx by x squared t equals to dy. V is minus. We have so minus 2xy t. This t will get cancelled off. This x and will get cancelled off. So you get dx x equals to minus dy by 2y. You can also write like that 2 dx x equals to minus dy by y. If you integrate both the sides, 2 ln x equals to minus ln y. Now, if we have the ln something in front of the ln, then we can write ln x square equals to minus ln y. Here we have negative. When we bring this one here, we become positive. Ln x square plus ln y becomes here 0. Then ln something plus ln something becomes multiplication equals to 0. Now ln x square y, what is 0? Ln 1 is equivalent to 0. So you get x square y is constant. Now you get which options? This. Did you get it?
Yes, ma'am.
All of you? All of you got that? Solutions?
Yes, ma'am.
Okay. Now let's try for the next one. This is a very easy one. Which one of the following stream functions is possible? A rotational flow field. Please mute yourself,
Hello,
and
ma'am.
after completion, you tell me the answer.
Ma'am,
Yes. Yes, tell
can
me.
we solve? Can we solve that previous question by using del psi by del x equal to v like that?
Previous problem.
Hmm.
You mean this one?
Yes, ma'am.
Why?
Means we have to find out the stream function, right? Psi.
Hmm.
Means the equation of streamline is nothing but equation of stream function in that way.
Yeah, I have said there are a lot many ways to find out. Okay,
Yes.
so if you want, you can find out and tell me, are you getting the same answer or not? This is another way.
Yes. Yeah. Okay.
All of you, please solve. Now, I want the answer from these people are active. I want who is not active in the class. Who is not active? We have so many people. Let me get the answer from Pavitra. Pavitra, you tell me the answer.
Ma'am,
Yes.
whether option B is the answer.
Yes, dear.
Whether option B is the answer.
We have to find out option.
We have found that it's like dou square psi by dou x square plus dou square psi by dou y square is equal to 0 for the second option.
All right. So let's find out how you have solved the problem. How you have, which formula have you used to solve this problem?
That's all. It's straight away, mom. It's like we have given the psi, I've taken it up to 2xy. So dou square psi by dou x square plus dou square psi by dou y square is equal to 0. It has been proved now.
Okay.
Option 2, ma'am.
So you have used this one?
Yes, ma'am.
Yes,
Del square psi by del x square plus del square psi by del y square equal to 0.
Equal to 0. It has to satisfy this. So,
Yes, ma'am.
so first let me try and solve it. So okay, you have to find for all the three, right? You have to find for all the three, all the four. Then only you will understand that which one is irrotational. Right? Now, do you find any shortcuts in that? Now, by seeing, can you say that which one is the right answer? Can you tell me? How to do the shortcut methods? See, first of all, to find the rotational, you have to double differentiate. So, whenever you will have any term less than that particular, here we have x power cube. That means somehow it will become, some factors will come after you double differentiate that. Here also you have square terms. So you will get some values. Here also we have somewhere we also have the square terms. So anyhow it will become not equal to 0, not equal to 0, not equal to 0. Right? So this is one of the shortcut methods. First you have to see, because this is a way that you can find. Since psi is given, you have to, this will be easy one to use this formula. Here it is having the double derivatives. So when you have the no powers over here, that means this will somehow tends to 0. Right? When you differentiate the second time, it will become to 0. So in the option, look into the options. Okay, first, if you have such kind of things, first look into the options. So whichever you have the less power, start with that. And whoever having more, just ignore it there itself. Just ignore there itself. You can ignore this 3 easily by seeing the options. You got my point? This is also another shortcut methods. All of you got the point?
Yes.
This is how you can save the time. You can
Yes, ma'am.
save the time. All right. Now let's move to the next question. Okay. So in this question, let's read the question. Component of velocity u and v along x and y directions in a 2D flow problem of an incompressible fluid. They have given four questions. They have given those who will satisfy the continuity equation would include. So they have asked which one will satisfy the continuity equation.
Ma'am, option 1, ma'am. 1, 2, 3.
Option 1. Okay.
Yes, ma'am.
So all of you getting the same answer?
Yes, ma'am. Option 1, ma'am.
Okay.
Actually, I'm trying to solve. One more minute, please.
Yes, please solve. So what you have to do, whatever the question is there, I will share that link with you guys. So you can take down that, or you're noting down the questions, right? So you practice the same questions. All are of different types. Okay, what you do is you practice the same problems. So if you practice this problem, definitely if one question comes from here, you can definitely attempt. Make sure with the symbols, negative sign and the positive signs. Can we move to next? All of you are getting the same answer. Pavitra, Tejasri.
Yes, ma'am, we can move forward.
Okay. Shall we move to the next?
Where you can
Or
get this recorded videos will be there in the website itself.
no, no, no. I will provide you separately. It won't be open source.
When we will be getting it.
Yes.
No, I'm asking like, will it be shared in the drive or something like that?
It has been, I'm saving, I'm in a YouTube. Okay. It is in a private link. So once I share you the link, you can look into that. Okay. Okay. Shall we move to the next?
Yes, ma'am.
Okay. Okay. Here comes another type of questions. Okay. Here the stream function is given. They ask the magnitude. Almost the same kind. Okay. Almost the same kind. So what you have to do is again you have to find the capital V. What is that? U square plus V square. Okay. After substituting all the points, you will get the answer. Now find out and tell me the right answer. So do not look back to the formula U and V. U is minus dou psi by dou y. V is plus dou psi by dou x.
Is the answer? I got it as a first option.
Which one?
4.24.
4.24. What about the others? Are you getting the same answer?
Yes, ma'am. 4.24.
Okay. All right. Okay. Now we have another questions over here. Now this is as I have explained, it is in terms of equations they have given. So from here you have to sort it out. What is U? U is 8x cube and V equals to minus 10 x square y. And you have to find whether the flow is rotational or irrotational.
I think the answer is rotational. The answer is rotational.
Sorry?
Yes, ma'am. Answer is rotational, ma'am.
Because it is not equal to 0.
It is not equal to 0, right?
Yes, ma'am.
Whatever you're solving, it is not equal to 0, so that it leads to an
Rotation. The
rotational
answer
one.
is 12x square we are getting.
Yes, absolutely. Now, there is one more way to find out the flow is rotational or not. Okay, there is one
Del
more
B
way.
by del X minus del U by del Y can we use, ma'am?
Yes, this also can
Del
be
B.
used. Okay, I hope you have studied the curl vectors, right? So you can use the del into V equal to 0. If this satisfies, that means it is an irrotational. Okay, the flow is irrotational. And if it is not equal to 0, that means it is a rotational flow. Okay. So you can, using this also, you can find out. Okay. All right. So now we will, yes.
I'm actually like, frankly speaking, I forgot the curl vector mom. So can you please write the curl vector once, please?
Sorry, curl vectors.
Yes.
Yes. It is like, it is nothing. We'll have I, here we have J, here we will have dou by dou X, here we have dou by dou Y, and in the third you will have whatever you have the U parameters, and here you will have the V. Okay. The same thing you will get dou V by dou X minus dou U by dou Y. You will get the same thing, isn't it?
Yeah. That's equal to what is given.
Yes. Okay.
Sure.
All right. This is a parameter means vorticity. Okay. Keep that in mind. Okay. Because this is a
Yes.
vorticity equals to twice of
So the
your
angular
angular
velocity.
velocity. And that means angular velocity is half of the vorticity. And what is the vorticity at the Z point? We have half of dou V by dou X minus dou U by dou Y. All right. Now, what you have to do, we have learned enough of that nature of the flows. I'm quite sure if you practice this problem quite rapidly, you can definitely attend one of the questions from here. Definitely. I'm quite sure. Now, you tell me, are you all aware of these questions? Can you identify the flow? Rotational flow, computational flow, irrotational flow, steady
Uh,
flow. Right. So today now we will look to some of the analytical techniques. Okay. So whenever we are okay. analytical techniques. So here we will see some of the analytical techniques. So there are many types or the techniques to analyze the flow. The first one is the integral analysis. Okay, integral. Second one is a differential, and the third one is a dimensional analysis. Okay, like MLT. Okay, first one is a integral analysis. Second one is a differential analysis, and the third one is a dimensional analysis, which we find through the experimental data. Now, to understand the basic of flows, we have the three basic laws. What are the three laws? Continuity equations, momentum equations, energy equations. Okay, when we deals with something a thermal impact, we talk about the energy equation. When we have some kind of forces acting on the fluid, or maybe the impact of viscosity, when we talk about the momentum. Now when we talk about the continuity, then when we talk about continuity, when we talk only the mass of fluid moving in any cross sectional. Okay, so the basic formula is m dot equals to rho a v, or a1 rho 1 a1 v1. That means if we have any cross section, okay, and fluid is moving along this cross section, maybe this is a and this is a1, this is a1, the density rho, here we have rho 1, this is v velocity, and this is v1. Then we can say the mass intake will be equivalent to the mass output, mass flow rate. Now what is the unit for mass flow rate? Not mass, mass flow rate. Mass flow rate. So we represent by m dot. Unit is kg per second. Now if I want to write in dimensionless number, what will be m
T bar by
L0 t minus 1. All right. Now considering this continuity equations, okay, let's talk about Bernoulli's equation or theorem. Okay. What is Bernoulli's theorem explains? What are the assumptions in Bernoulli's theorem? Can anybody say? There are
Incompressible.
the flow is first steady. It is a steady flow. Second was it is a incompressible flow. Third was irrotational flow. Fourth one, what is the fourth one? That is a total energy is constant. Total energy is constant. Okay, this is the principle. Now, where we can use this Bernoulli's principle in our aerospace, where we can use Bernoulli's principle.
Lift generation.
Lift generation over where?
The wing.
Yes, we lift generation over the wing. What it does in that, when we have some certain angle of attack, bottom we have the high pressure, we have the low pressure. Now where the pressure will be high, what will be the effect with the velocity? Velocity effect?
Opposite of that. Inverse, ma'am. Inverse.
Velocity will be low, and here the velocity will be high. Now, apart from that, the same phenomena also occurs in a car vehicle. Okay, the same phenomena is also occurs in a car vehicle. Now, it has been derived from the Euler's equation by integrating the Euler's equation. So finally, you get an equation like P1 plus half rho V1 square equals to P2 plus half rho V2 square. Now, one of the implementation is, as I've said, airfoils. Second, it can also use in a car. Third,
Ma'am, are
it
you
is
writing
also,
anything, ma'am? Hello?
yes, I'm writing.
Ma'am, it is not visible, ma'am, in my
What you can see? Can you see this equation?
continuity equation, ma'am, only.
No, after that I have written. Can you see that I have boxed that formula?
No, ma'am.
What you do is, nobody can see that formula. Nobody can see that. I request, please reload the session.
I'm not able to see it.
Those who can't see, please reload the session. Okay. All right. Could you able to see now? All right. So please remember, this is the formula for the Bernoulli's equation. Okay. P1, and yes, I was talking about the application where it is applicable. It is applicable in the aircrafts, airfoil. Then not only that, the wind turbine blades. Okay. Even it can be implemented in a wind turbine blades. Okay. So let's not go much deep into wind turbine blades. All right. So this is the formula. Now, what it signifies, whether it is satisfy in which region. When we talk aerodynamics, okay, which region it can, whether it is subsonic, supersonic, transonic, which zone it satisfies, or hypersonic, where it satisfies, where this
Low
equation
subsonic.
is satisfied.
Low speed,
Low subsonic.
Low speed. Now we have lot many conditions. 0.3 less than Mach number, 0.5 greater than Mach number. When you have 0.8,
less
have
than
1.
0.3, ma'am.
Yes. Why we have less than 0.3?
Incompressible flow.
Yes, absolutely right. So they can give where the Bernoulli's equation will get satisfied. So they can give you this kind of couple of options. So you have to understand that how the nature of the flows. Okay, whenever the Mach number is less than 0.3, okay, less than 0.3, that means if the flow is still and incompressible. Once it started to move 0.3 or higher than that, the it started to begin a compressible in nature. Okay, started to begin in compressible in nature. All right. So understand the parameters. So here we are only talking about incompressible when the Mach number is less than 0.3. Okay. Now, what happens when the area changes in this particular region? What happens if the area changes? Let me erase this part. What happens if the area changes? If we have let's take up one condition. This is a first one, what I've drawn, it is an convergent or divergent. What type is that? Flow is entering. This is a convergent or divergent?
Convergent.
Convergent.
Convergent, ma'am.
Convergent. There are something that is still sometimes get confused that whether it is convergent or divergent. Understand the term that is converging. Okay, that means it is the both the wages are coming in closer with each other. Okay, so when both the edges are coming in each other, if this is the area A1, this is the area A2, it is coming, it converge. Okay, keep that in mind. Now next comes, sorry, I have drawn wrongly. Now this one, what is this? This is convergent or divergent? Now flow is entering from here.
Divergent.
It is
Divergent.
a it is a divergent. Very good. Now what happens with the flow? What happens with the flow? Let's consider here we have the V1, P1 at the pressure P1, velocity V1. Similarly, here we have the P2 and V2. What will happen in a convergent and what will happen in the divergent? Let's first consider the convergent. What will happen here? When the
Pressure
flow
decrease, velocity increase.
velocity,
Increase, pressure
that
decrease.
means when it comes over here, the velocity will, that means the V2 will be more as compared with V1. So if velocity increases, that means what will be the impact with the pressure? How the pressure P2 and P1 will be related? What will happen? That means P1 will be having more pressure as compared with P2. P2, as the velocity increases, what will happen? The pressure will decrease. The pressure will decrease. And in case of divergent, so that is one of the main reason. If you see in our gas turbine engine, like if you consider for an you know turbofan and turboprop engines which is flying within less than Mach 0.67 and all 0.78, so they are preferring to use the convergent type. The reason behind, if they are making the convergent, what will happen? The pressure will decrease. That means the pressure loss will be decreased and they will get a exit velocity will be more. That means exit velocity is more means the thrust will be again more. Could you relate that?
Can you tell it again, ma'am, please?
Okay, all right. So here in our gas turbine engine, let's consider gas turbine engine. Okay. So let's consider a simple schematic diagram. Okay. So if you look into nozzle, it is gradually converging, right? It is gradually converging type. Now, what is the benefit in this converging? I think please mute yourself. There is a huge buzz noise. Yeah, thank you. So, if at certain pressure and certain velocity, all right, and when it leaves here, we have certain pressure and certain velocity. Now, what happens over here? Since, as we know, the V2 will be more than V1. Now, what means V2 means it is at the exit. If the exit velocity is more, that is V2 is more, then automatically the thrust will increase. Do you agree? The thrust of the engine or thrust produced by the engine will be more. All right. So this is one of the main reason that why they use a convergent type. That means the area that is A1 and A2. A2 will be smaller than A1. So pressure loss, the P2, okay, at the exit, P2 will be less as compared with P1. So that will also leads to an decrease in pressure loss. All right. Did you get the point? So let's move to the next is the divergent. Now in the divergent, what we have, the area is A2 is greater than A1. Now in this mechanism, what will happen? At same amount of P1 V1 and P2 V2. So you just remember this concept of a gas turbine. You will remember here will have the opposite or reverse of that one. Now here it will decelerate the velocity. That means V2 will be less. V2 will be less than V1. That means V1, whatever the velocity, it will be lesser than that. That means here what will do? Decelerate the flow. Okay, here they will decelerate the flow. And what will be the happening with the pressure? Right? Pressure will be more. Since the velocity is less, pressure will be more as compared with that. Okay. Now, relevant there, this is one of the very important topic relevant to that. Sorry, they can ask lot many connective questions. Okay, they can ask about adverse pressure gradient. So we will move to that when we were discussing about the boundary layer and all. So we will discuss. So this is deaccelerated of the flow can helps to increase the pressure gradient. That means what is adverse pressure gradient? That means drastically the pressure is increasing at change in respective distance. Okay, so again it can play an important role. So please keep that in your notebook, that due to this kind of phenomena, okay, this adverse pressure gradient can also actively play a great role. Did you get the point? Let me know. Can unmute and let me know.
Ma'am, come again, ma'am. Once again, explain, ma'am. Adverse pressure gradient, deceleration velocity.
Okay. What is the meaning of adverse pressure gradient means? Is my marker gone? Okay. Let me change the color. Adverse pressure gradient means that there is a rapid increase of pressure with respect to some kind of distance. That means it's some change in distance. Okay, there is a rapid increase in pressure, change in pressure with respect to change in distance. Now, when it happens, when there is a concept comes about the decelerated flow. Okay, the flow is getting decelerated. That means velocity is getting down and the pressure is increasing. The same thing happens in the boundary layer. Suppose you have a surface, flow is moving over the surface. Okay, suddenly due to the deceleration, if I take as this one as a reference, it started to move reverse path and then it will move. It will start to move in an opposite direction. Okay, or we can say flow separations. Okay, this leads to increase in flow separation. So this phenomena leads to an adverse pressure gradient. When there is a flow separation, that finally leads to an adverse pressure gradient. So we will look more in deep. Now you just remember deceleration occurs, that means flow separation will leads to an pressure gradient. When we will come to the boundary layers, and that time we will focus more into this topic. Okay, all right. Now one more big applications, another great application is wind tunnel. I hope all of you know the wind tunnel. So here we are talking about subsonic wind tunnel. Here we are talking about subsonic wind tunnel. So what happens in the wind tunnel? So what are the components? I think all of you know about the components of wind tunnel. Can anybody tell me what is solid wall blockage in a wind tunnel? What is a solid wall blockage? Anyone? What is a solid wall blockage? I hope you have heard before. Solid wall blockage. Anybody?
The obstruction in the flow field inside a cross section, the test section by some unwanted particles are stuck to the surface of the walls.
You are closer to the answer, but not a precise answer.
Actually, it is interrupting the flow over the specimen. Hello.
Am I audible?
Yes, now you're audible.
Slides are. You can see the slides.
Yes, yes, obviously.
Okay.
Actually, because of the solid wall blockage, the flow over the test specimen inside the test section will be interrupted. As a result, the pressure measurements will not be very much accurate, I guess.
Yes, somewhat connecting, but
Reverse.
all right. Yes. So first, if this is a test section, okay, you are keeping a airfoil over here. You're keeping an airfoil over here. Now what will happen? So it depends. Suppose the cross section of your wind turbine is 120 mm. For an example, let's consider a small wind turbine, 120 mm. Okay, here we have a square one. Square one, maybe you have 40 mm, and here also you have 40 mm. All right. Now volume. Now you can find out the volume of your airfoil, whatever the object you are finding out. So the main concept is the volume of the component which you are testing inside the test section should be the volume of a test section. The volume of a test section should be greater than the volume of the object you are testing. Okay. If it is almost equivalent, there is a ratio. It should be of 3 to 4 times of the volume of the object. Okay. So why they keep the 3 to 4 times? To capture the flow inside the wind tunnel. To capture the flow. Suppose if I keep a huge airfoil over here, okay, the second airfoil which I'm drawing in the same cross section, right? So when the flow will come from the settling chamber from the nozzle, whether it can capture the flow, it can't, right? The flow will get distorted by the walls. When it hitting the walls, it will get reflected back. Yes.
Sorry to interrupt now. Are you drawing something right now?
Yes, definitely.
Like, have you drawn an airfoil?
Sorry, I'm.
Like, have you drawn an airfoil or something right now? Because I'm not able to see it.
Do nobody can see that or what? Just give me a second. I will reconnect my internet. I think there is a huge interruptions in my internet today here. All right. Just give me a second. Is it visible right now?
Yes, ma'am.
Yes, ma'am. Visible, ma'am.
Okay. Okay. Now I was drawing the bigger airfoil. A bigger airfoil. If it is here, when the flow comes from the settling chamber, okay, and heat to the airfoil, when it will come, it cannot capture. So there will be a turbulency form because all the flow will be haphazardly moving along each other. So the reading in the manometer, when you're measuring over there, you cannot get the proper reading. All right. So it is, so this phenomena is called as a solid wall blockage. So you have to maintain when you're designing the wind tunnel. So you have to maintain the volume of the test section should be 3 to 4 times more than the object. Okay, whatever the object. So usually we don't create that. We have some particular well-defined test section. So based on the test section, we define what will be the size of our object. So accordingly, we design the prototype. Accordingly, we used to design the prototype. Okay, so this is a solid wall blockage. It can also can lead to reflections, and reflections all will be haphazardly reflecting back. The flow won't be laminar over the airfoils or whatever the components you have. All right, you got the point. What is a solid wall blockage? Please respond so I will know.
Yes, ma'am.
Okay, now we have the few components: settling chamber, nozzle, we have the test sections, we have the diffusers, and you will have the extensions, fan, rotors. Yeah, I hope all of you have done the wind tunnel testings and all. So here it plays another important formula. Okay, use the same Bernoulli's principle over here. And using the Bernoulli's principle, they considered the V1 entering V1, A1. Okay, when they're entering the test section, V2, P2, A2. When it's leaving, V3, P3, A3. Because cross section is changing. All right. Now, another concept called contraction ratio. Contraction ratio means that is A1 by A2. Always the contraction, that means area A1 should be greater than A2. That is A2 is in the test section. A2 to 15. Again, it depends which based on the test section size and so on. So sometimes they may ask a question like, what are the expected wind tunnel contractions ratios? So mostly it is to range between the 12 to 15. Okay, that means area between the intake and entering into the test section. That is meant by the contraction ratio. Okay, now there is a relation we have. This is V2 equals to twice of P1 minus P2. Again, we no need to look into the derivation. Here, just remember the formula A2 by A1 whole square. Now again, most of the time, majority of the time, they ask a question from here. Majority of the question, if you look into the few years back question paper, you can find they ask the question. Now this formula can also be written as, okay, rho G del H by, twice of, okay, this is a rho of mercury, okay, this is a rho of air of free stream velocity, 1 minus A2 by A1 whole square. All right, this is the formula. Sometimes you may get confused with that, so please ensure this is the density of the mercury. I hope you know the density of the mercury. What is the specific?
13,600.
13.6 into 10 power 3 kg per meter cube. Now talking about density of water is 10 power 3 kg per meter cube. So these are the few values you have to remember. Now G, what is a G value is 9.81. Okay. All right. So based on the given data, you have to find out. Okay. So we will do the problems in the next class. Okay. Now I will quickly give you what is strict line, path line, and stream tube. Okay. So it's a very easy concept. Path line, streamline. You should know the nature of these things. Then we have strict line. Then we have timeline. Timeline. Okay? Timeline. Now, path line, when we can say? That means when a fluid is moving, let's consider moving in this way. Moving in this way. Now, let's consider the fluid, small particles like this. Let's consider. So, which well-defined path it is moving, that is called as a path line, which is irrespective of time. We are not seeing the time. It is moving at some initial time, and when it reaches to something, reaching some final time, but irrespective of considering the time. All right, the flow can be either steady or unsteady. It also depends. Okay, this is a path line. Streamline, whatever the flow we have, each and every point there will be some tangent. Okay, there will be a tangent flow on that, from that point, and this tangent will never coincide with each other. These tangent lines will never intersect with each other. Okay, so that is, and one more thing, any two streamlines will never overlap each other. If there is one more streamlines, okay, they will never overlap each other. That means it is a well-defined flow. They will never coincide each other. Okay. Next comes strict lines. Strict lines is moreover like an turbulent flow. It is like moving, just like a smoke coming out from the chimneys. The best example. Okay, the smoke coming out from the chimneys. All right, are you getting the point? Are you getting the point? Let me know.
Yes, ma'am.
Yes. Now what is the difference between this streamline and strict line? Okay, it is basically a path will be followed. Okay, it is depends how long the path is moving. It depends on the distance. If the flow is moving from one point to another point, how long distance it is been traveled. Okay, how much distance it has been traveled by its movement, in each and every interval. That is, in simple words, we can say a straight line. Now, when we consider the time, right, when we consider the time, we take as a timeline. When any flow moves from one point to another point, okay, any point, one point to another point, when we define that flow with respect to time, it means it is a timeline flow.
Excuse me.
Yes.
Can you explain streak line once again?
Hello.
Can you explain streak line once again?
Yes. Strict line is very simple. It is a well-defined path. Okay. It is a well-defined path. Okay, which represents based on its kind of length, how much distance it has been traveled. Suppose if I what it happens is, suppose we have some points. Okay, I am making some points, 1 2 3 4 5 6. Now when I'm moving from 1 to 2, okay, when I'm moving from 1 to 2, I will be seeing how much distance I have traveled for the 1. When I'm moving 2 to 3, I will see how much distance I will compare with the previous one. Okay, now 3 to 4, when I'm moving, I will see how much distance following with the previous. Sorry. Okay, it is just a path which defines with respect to the previous one. Suppose I'm moving here, how much distance or travel or whatever it is, it will depends with the previous one. Okay, it relates with the previous one. And all the three, the path line, streamline, and strict line, becomes equal. Sorry. If the flow is steady. Okay, if the flow is steady flow, that time the path line, okay, path line will be equals to the streamline, will be equals to the strict line. So, however, the randomness of the flow, it will be defining how the flow is moving from one point to another. That's what the strict line defines. Path line is a general, like however the flow moves from one point to another point, that defines the path line. Streamline means, that means it is a laminar flow. It defines a moreover like a laminar flow. Timeline is however the flow moves, it depends the motion of the flow with respect to time. Now, did you get the points? All the 4? Let me know.
Yes, ma'am.
Okay. So this is a general idea for the path line, streamline, strict line. And this path line, streamline, strict line becomes same when it is steady. That means all will behave in a same pattern. Okay. Timeline is not coming because it depends with the time. And what is a steady flow? It shows that is dou pressure by dou time will be constant. So it cannot take part with that because it depends with the time. All right. Did you get it? So any questions you can ask? Any other questions you have in your mind, you can ask. So you can expect questions for you. I think Tuesday will be having the again that won't be a open book test. Okay, that won't be the open book test. That will be the real test. So keep that in mind. One more thing, I have made a video. All right, I actually today I have released one video in the YouTube channel, that strategies that you have to follow. Okay, so please have a look into that video. I think it will be helpful. I just couple up with the ideas with a lot many people have given me the advice that you should do this way, that way, and all. So I have compiled all together. I have made one video. So I think that video will really help you all. Okay, so whenever you're doing in the rough sheet, do not scribble in the rough sheet. Okay, never ever scribble in the rough sheet, and look into the question carefully, read the question carefully. And for your upcoming, coming Tuesday, when you will be having the exam, coming Tuesday you'll be having exam for the aerodynamics alone. That means whatever I have taught, the questions will be from here. That means identification of flow, the basic properties of the flow, viscosities, and path lines, streamlines, strict lines. Okay. uh, Yes. What you have to do whenever there is a problem, you carry a separate rough sheet with you. And what you have to do after completion of the exam, you have to send that rough sheet to me. Okay. I want to see how you have solved the problem. Okay. Then only I can guide you in a better way. Okay. Did you get it? You can now unmute yourself.
Can we get some more questions to solve on the nature of